Hi everyone, I'm Vipin Kumar, founder of Arpim Tutorial. Welcome to my channel. I'm going to talk about surface areas today. Surface area topic is of very practical significance. It is related with finding the surface area whenever you want to, say, wrap a object with certain material, or maybe you want to paint an area or an object, right? Then you need to know the surface area and corresponding what will be the cost involved for any of those activities, right? We will be talking about common shapes like cuboid, cube, cylinder, cone, sphere, hemisphere. Let's look at cuboid first. So cuboid shape is like this. The edge which is appearing on the back side, I have shown it with the dotted line. Okay. Let this be the length of the cuboid, this be the breadth of the cuboid, and this be the height of the cuboid. Then, as you can see that there are 6 faces of the cuboid. One face this side, which is having breadth and height involved. And just opposite to that, there will be this face also. Similarly, if we take the lower face, which involved breadth and length, the corresponding there will be one upper face also involved. So every face is having one face opposite side. So therefore, there are total 6 faces for a cuboid. Okay, and therefore the total surface area of each face inclusive will be, say for example, take this, the base one, it will be L times B, and just opposite to it there will be another, so there will be another L cross B, right? Similarly, if we take this face, then it will be B cross H is the surface area for this face, and just opposite to this face there will be this face also available, which will be B cross H. Similarly, there will be L cross H, this face, L, and this is H, so this face, and just opposite to this will be this dotted line, this solid line, and this solid line, another face, right? So that will be L cross H plus L cross H for each face, one the front, another one in the back. So what we get, therefore the total surface area will be equal to 2 times L into B plus B into H plus L into H. And that is how you get the surface area of the cuboid. The formula 2 times L into B plus B into H plus H into L or L into H. Okay. Let's look at the next part, that is lateral surface area. When we talk about lateral surface area, it involves only those faces which have height involved into it. So you need to then exclude the one face which is having at the base and just opposite to that, which is the face at the top, because that does not involve height. So then the lateral surface area will be equal to the one which is having base into height, this, and then similarly this face which is base into height. So because there are 2 faces, there will be 2 areas involved. Likewise, this L into H, this front face, and correspondingly the back face. So L into H plus L into H. And therefore lateral surface area will be 2B into H plus L into H. That is how you get the lateral surface area of the cuboid, which is 2BH plus 2LH. I would urge you people to remember this formula in this format only, that there are, so 2LB plus 2 under bracket LB plus BH plus LH, or 2BH plus 2LH, because at times when you are solving problems, the surface area identification cannot be done by one generic formula. It is always better to understand the surface areas in its component form. So what all constitutes that area and what is the corresponding surface area of that portion and how it sum up to create the surface area of the entire structure. Okay, but at times there are problems related with this where one face may not be available. And if you just simply go and do this 2LB and BH and LH, probably you will be going wrong. So it is better to understand that which all faces are involved and then what is the area of those faces. Likewise, which all parts of the shape is involved and then what are the corresponding areas for that. Okay. Let's go about the surface area of a cube. So cube is distinguished by the similar kind of three-dimensional structure, but all faces, all edges are of same length. So if I have to draw the cube, it might be appearing like this and like this. So this is appearing like a cube where all edges are of the same length. So for example, if this is A, then this will also be A, the height will also be A. So length, breadth and height all are equal. Now as you understand that for one face the surface area will be A into A. If we take just this one face, so this will be A square. Likewise, opposite to this, there will be another face. Similarly, the front face and the back face, so again A square plus A square, and one face at the bottom and one face at the top, so it will be again A square plus A square, and that is how you get 6A square as the surface area for the cube. Okay. It's very important to visualize the object and accordingly decide what will be the surface area involved. And it is always better to look at all the components involved of the surface and then what are the corresponding areas. Because when you're solving the problem, you have to apply those visualizations properly. Okay. Let's come to cylinder. Cylinder shape is like this. The base is circular, the top is circular, and then this is the height of the cylinder, and then will be the radius of the circular base. Okay. So for finding the surface area, if you just cut open the cylinder mentally and expand it, this will get expanded like the entire circumference will get open and this length will be 2 pi r, right? And then the surface area involved will be, now it is kind of a rectangular shape that it got open, and then this part will be of the height h only. So therefore the surface area of a cylinder will be 2 pi r into h. Okay, that is how the curved surface area of a cylinder appears. Be clear about it that here we are talking only about the curved portion. This portion of the cylinder is the curved portion. So we are talking of the curved surface area, CSA, curved surface area of a cylinder, and that is 2 pi r h. Now let's look at the total surface area of the cylinder. If we consider the total surface area of the cylinder, then the base circular part and the top circular part also comes into consideration. So then curved surface area is 2 pi r h, but total surface area will be the base, which is a circular one, so pi r square, the top, which is again a circular one, so pi r square, and then whatever curved surface area we just learned. So this curved portion will be the curved surface area, and that will be 2 pi r into h. And therefore, total surface area will be equal to 2 pi r square plus 2 pi r h. Thus, what is written here, the pi r square plus 2 pi r h, that becomes the total surface area of a cylinder. Let's talk about the surface areas of a cone. So, a right circular cone will be appearing like this. Okay, you have eaten the ice cream, and some of the ice creams are put in the shape of cone as well, right? So this is the shape of the right circular cone. Now, if radius of the circular part is r, and from the vertex this length is or height of the cone is h, then this angle is always 90 degree, and this height is called slant height of the cone. And slant height of the cone, you can see that this is kind of right angle triangle, and here the slant height is appearing like a hypotenuse of this right angle triangle. So the slant height will be equal to under root r square plus h square. The curved surface area of the cone is given as pi into r into L, where r is the radius of the cone and L is the slant height of the cone. Okay. Again, so this is curved surface area, the curved part of the cone. If we have to find total surface area, then the curved surface area plus this circle, the upper one, the circle is pi r square, so that is the area of the circle, plus the curved part of the cone, that is pi r L. So the total surface area of the cone will be pi r square plus pi r L, because this circular part on the top also comes into picture when we find out the total surface area. Okay. Now let's talk about a sphere. So if we consider the full sphere, understand that this is a three-dimensional figure. This is a sphere like a ball. It is not a circle. For a sphere, the curved surface area will be equal to 4 times pi r square. Okay, where r is the radius of this sphere. Okay, now if we divide this sphere like a spherical piece, like a spherical ball or complete spherical iron ball into half, if we cut it half, then that becomes the hemisphere. So this is hemisphere. Okay. Now, if we have to consider, if we have to find out the curved surface area of hemisphere, it is obvious that we have halved the entire sphere. So corresponding the curved surface area also will be halved. So it will be half of 4 pi r square, which is the surface area of the entire sphere, right? But in the hemisphere, it is cut into half. So the curved surface area of hemisphere will be half of 4 pi square, and therefore it will be 2 pi r square, which is written here. Now, if you have to find the total surface area of hemisphere, then as you can notice that even this part, which will be a circular part, if you cut the sphere into half and see from the top, this will appear like a circular part. So then you will have to add pi r square for this circular part, and then you have curved surface area of 2 pi r square, and therefore the total surface area of hemisphere becomes 3 pi r square. So with this analysis of all the surface area of the regular figures, you would have understood how these formulas have come. I would again recommend that try understanding all these formulas, basis all the different parts of that shape involved. Because when you are going to solve the problems, not necessarily that entire surface area will get involved. It might be a part of the surface area also. So therefore, it is always better to understand the formula or representation of the formula in its constituent form, and whatever constituents are not applicable, you need to exclude that part. Whenever you are solving the problem of surface area and including surface area and volumes, the visualization is very important. So you need to visualize the object, and then also that which portion of the object is coming into play in a particular problem, which portion is not coming into play, and accordingly you'll have to exclude the volume or the surface area of that particular object. So never directly mug up all the formula. Just notice that what are the constituent part, the way I have explained it, and then accordingly remember it, and whatever is applicable you need to apply only those portion of the surface area. I'm hoping that with this analysis, the thinking of the surface area in terms of its constituents and components is clear, and then in the next videos we'll be taking some examples also so that you can understand it better. With this approach, probably the fundamentals of this is clear to you. Okay, thank you.